Well, hello there. This is video number 18. And it's called Applications of Rational Equations. It's chapter 4, section 6. Applications of Rational Equations. But prior to actually getting to this topic, we need to talk about some prep work. And that is something called algebraic translation. I've never personally been very good at it. I think some of you are going to mentally shut down. So I'm going to challenge you to try to stay present, try to focus on what's happening. I'm going to give you a couple of strategies and a list of common terminology that might help you. I've also linked into Google Classroom 2 other videos, one with some strategies, one that is a pretty basic video on how to set some of these up. And I'm going to go through lots of examples before I even get to chapter 4, section 6. Okay. So what we're talking about here is turning English words into algebraic expressions or equations. For example, I'm going to read one here. 7 is 3 less than 4 times a number. Ugh, that kind of stuff. So that's where we're going. Ultimately, we're getting into reciprocals of things. So what I want to do is give you some common terminology and ways for you to list these things. So common terms in English and what they mean in math. So here's a list of terms for adding. Some terms that they might use are the words plus, increased by, right? 5 is increased by n, 5 plus n. More than, sum of, remember that sum means add, and total of. Okay, so that's just a small list of words that mean you should add. Here is a list for subtraction. This is minus. That one's pretty obvious. Difference of. Remember that a difference means subtract. Decreased by. I don't have enough room there. Less than. Okay, those are just a few of those. And then I have a warning for you. A note to be careful. The less than construction. Is backwards in English. As compared to math. So here's an example of what that means. 2 less than x, or less than a number, whichever way you want to put that, means x minus 2, not 2 minus x. So it's backwards. The number comes first. 2 less than. They talk about in one of the videos the word than being something called a switch word. And I like that because it indicates to you to switch these two things in the order. If you see the word than, less than, switch the two values. Okay, so that gets a lot of people when it's subtraction, and things like the ACT do that to you all the time when you see these kinds of things. Okay, let's do multiplication. Words that mean multiplication. Times. Product of. Remember, a product is the answer to a multiplication problem. Product of. Twice. Or triple. Or something along those lines. And then you could see something by increased or decreased by a factor of. So if something is increased by a factor of 2, that would be 2x. Okay. And that can also involve addition, subtraction, and multiplication all at the same time. And then we'll do division. So ratio of. Per means divide. Out of means divide. Quotient of means divide. And then we're going to end up, make sure that you know what the word, you need to know that reciprocal means a flipped fraction. That's going to come into play later in ours. All right, and then you also need to know different terms for equals. So those are is, are, was, were, will be, gives, yields, sold for, and costs. Those are just a few of the ones that I picked, the more common ones that I picked to share with you here. All right, so where we're going from there, there's a list. You should keep that handy. And I don't know if you want to actually write them down somewhere. Maybe take a picture of that page and have the picture handy as you go forward if you're going to continue on. So, okay, what we're going to do here is I'm going to write 4 different expressions, and I want to know if you can write the algebraic expression for it. So, can you write the algebraic expression for the following statements? So we're going to have A, B, C, and D. A, 5 increased by an unknown number. B, 3 less than an unknown number. C, an unknown number tripled. And D, 4 more than twice an unknown number. Okay, so what I'd like you to do is pause the video, write out what you think the answers are for A, B, C, and D, and then come on back and see if you were right, because this is the very beginning. This is the start of these. They only get more difficult from here. So pause, come on back. All right, well, welcome back. Hopefully you took a minute to answer these questions. So I'm going to write the answers to these in red, and keep in mind an unknown number can be any variable, right? I'm going to use X. I usually do, but you could have used P, Q, M, S, R, V, N, whatever. So 5 increased by an unknown number. 5 increased by an unknown number. That would be 5 plus X. Okay. 3 less than. Well, there's that switch number. So I'm going to have a less than. The 3 is going to go over here, and an unknown number is going to be X. So that would be X minus 3, not 3 minus X. So that's important. They're very different from each other. Addition, it doesn't matter what order they're in. Subtraction, it does. An unknown number tripled. Tripled means 3 times something. So this would be 3X, an unknown number tripled times 3. All right, and then this guy is 4 more than. So 4 more than twice an unknown number, which is 2X. So this could be 2X plus 4, right? The top one could be X plus 5 instead of 5 plus X. This B can only be X minus 3. So if you had 3 minus X, that would not be correct. You need to make sure that that's in the right order. Okay, so those are some fairly straightforward ones. Now I'm going to do, I don't know, a couple different examples where we're going to set up an expression, and then we're going to do a bunch where we're actually going to solve some equations. And hopefully these get easier and easier for you as you go. So next, we have a statement that says, well, this will be an A. That's an A. That does not look like an A. 3 times an unknown number decreased by 5. That's not all. Decreased by 5 times an unknown number. Write the algebraic expression and simplify. Okay, so we have some information here. We have 3 times an unknown number. Well, that's 3x, right? And then we have this decreased by. Looking back at your list of words, decreased by means subtract. And that's, you don't have to change the order because the than is not in there, which is the switch word. 5 times an unknown number, which is 5x. This unknown number is the same unknown number. So you can use the same variable when you do that. And then we can just combine like terms and we get negative 2x. And that would be the answer to that guy. Okay. All right, here's another one. B. What is the difference between a father's age and his son's age if the father's age is 3 times his son's age? Okay, so we're just going to take what we see and then go from there. So what is the difference? We know we're doing a subtraction problem between a father's age and his son's age. If the father's age is 3 times his son's age, so we know nothing about this, so we'll let that be X because we don't know anything about it. And the father's age is 3 times that. So we have 3x for the father minus x for the son, and that equals 2x. And we don't have any information here about he's 40 years old or whatever. So you can't actually find his age. It's just asking for an expression that tells you that information. So that would be 2x. Okay. One more of these before we move on to solving. This is C in this guy. Find the sum of an unknown number and 3 times an unknown number. Okay, so find the sum. This tells us we're adding. And find the sum of an unknown number. Well, that's going to be x. And 3 times an unknown number. Well, that's going to be 3x. So we're going to have x plus 3x is 4x. So we don't know what the unknown number is. We're not being asked to find that. We're being asked just to find the sum. In the next bunch, I think I have 10 examples. We are actually finding the value of n. So you might want to take a break at this point, grab something to eat or drink, go to the bathroom, come on back prepared to solve some problems. And because these are all in English, there's a lot of writing. It's kind of terrible. I can't pause. You can. All right, so now we are solving. So I think I have A through H for these. A, 5 more than n equals -4. All right, well, 5 more than n means 5 plus n equals -4. And then you're simply going to solve. Now that you've turned it into a math problem, we know we're going to take 5 away, and n equals -9. Okay? B, I'm starting with these fairly straightforward, right? So that you know how I am. I start easy, and then I make things much more difficult as we go. So this one is weird. It says twice n less 3 equals 5. All right, well, twice n is 2n. Less means minus. It doesn't say less than. We don't have to switch anything. It just says less, which is in your minus category. Less 3 equals 5. So there's your algebraic expression. And now this is pre-algebra. You guys can do this without even doing any work, probably. Add 3, so you have 2n equals 8 and n equals 4. Okay? C. Turn my paper over here. All right, 1/2 of n. 1/2 n is 4. More than n. Okay, so again, let's turn these into some words. 1/2 n. 1/2 n is means equals. Go back and take a look at your list that we made on the very first slide, if you don't remember. 4 more than n. It doesn't say 4n, it's 4 more than, which means to add. So this is 4 plus n. All right, well, now solve. I'm going to keep my n positive. So I'm going to move the 4 over here and the 1/2 over here. So that gives me a -4 equals n minus 1/2 n. 1n minus 1/2 n is a 1/2 n. And then to solve that, we're going to multiply by 2 and multiply by 2. The reciprocals cancel each other, and I get -8 equals n. Okay? Excuse me. D. 3 less than 5 times n. 3 less than 5 times n yields 12. Oh, I'm going to squeeze this in here. Yields 12. All right, so what does this mean? Less than, subtraction, and it's your switch word, right? So the 3 is going to go on that side. 5 times n is 5n, and it's going to go on that side. Yields means equals 12. Okay, so that's how we're going to take these apart and then make them simple for you to do. Add a 3, 5n equals 15, n equals 3. All right. E, and then you're going to really love F, G, and H. E is 7 is 3 less than 4 times the number n. 7 is less than... Oh, no, I did that wrong. Erase. Oh, that's not erasing. Oh, geez. Okay. 7 is 3 less than 4 times the number n. Okay, so 7 is, remember, is equals. So 7 is 3 less than, switch word. Okay, so the 3 is going to go over here. 4 times a number goes over there, right? Because they get switched. And now we're going to solve. So add a 3. 10 equals 4n. Divide by 4. And we can reduce. N is equal to 5 over 2. And that's what we would get. Okay, now some word problems. Utilizing this information. This, for me, this is where the challenge personally comes in. I have some issues with these. So this says one team scores 3 more than twice the number of runs oh geez, typo, number of runs as the other team. The winner scores 11 runs. What is the loser's score? Just as a weird note, I would say, how many runs did the loser score? What is the loser's score? I don't know. Weird. Anyway, okay, so what do we know absolutely nothing about? We actually know nothing about the loser's score, right? So since you know nothing about them, then they are X. We actually know nothing about them. Now, the other team scores 3 more than twice the number of runs. So actually, I'm going to do that. We'll do that in blue. 3 more than twice the number of runs. So 3 more than twice the number of runs as the other team. They clearly are the winners, right? So these are the winners because they score that many runs. And they score a total of 11 runs. So if we find out what X is here, then we know how many runs the losers scored. So we're just going to solve this guy. So I subtract 3, 2x equals 8, and x equals 4. So the losers, I hate that word, losers scored 4. And the winners scored 11, which is 2 times the number of runs and add 3. Okay, so the losers scored 4. Okay, G. This is problem G. Actually, I'm going to go put this on another page. Okay. Ruth is twice the age of her brother. The sum of their ages is 15. Now, if you're like me, I just went, oh, they're this old and this old. But I need you to show work. How old is Ruth's brother? Okay, well, we don't know anything about the age of her brother, so he's X. Okay, Ruth is twice his age, so Ruth is 2X. The sum of their ages is 15, so X plus 2X equals 15, 3X equals 15, X equals 5, so this is the brother's age. And if they wanted to know, then Ruth would be 2 times that, which would be 10, right? Okay, now here's kind of a fun one. This is a good algebraic problem that you might see on an ACT, actually. This is problem H, and it says a pair of socks and a shirt cost $40. The cost of the shirt is $5 more than 4 times the cost of the socks. What did the socks cost? Okay, I like this question because you're actually dealing with 2 separate things. So if you have 2 items, you need 2 variables. Excuse me. And so what I'm going to do is give the socks a variable of X and a shirt a variable of Y. And we know socks and a shirt cost $40. I'm just trying to color code for you here. All right, now it says the cost of the shirt is $5 more than 4 times the cost of the socks. All right, so, excuse me, the cost of the shirt is Y, is $5 more than 4 times the cost of the socks. So 4 times the cost of the socks, and socks is X. Okay, so remember that is and equals. So we have Y equals 5 plus 4X. And now I can use substitution. I can put this in for the Y over here. So now I have only X's in my equation. So I take this X here plus 5 plus 4X equals 40. And then I'm going to do the math. So we're going to use substitution. So I have X plus 5 plus 4X equals 40. 5 plus 5X equals 40. Subtract off the 5, so 5X equals 35, and X equals 7. And X was originally the cost of the socks. So the socks cost $7. Okay? Kind of a fun problem. All right, now let's do what we're really here to do. All right, so all of that was prep work. And I only have, well, I guess I have a couple of problems that we need to work through. So here is really what we're doing now. Remember, this is applications of rational equations. So this is prep for varsity questions. All right, so we needed all of that so that we could do this. Here's the first example. This is for your homework. It says one number is 3 times another. Period. The sum of their reciprocals is 8/3. Find the numbers. Okay, well, here's what we know. One number is 3 times another. So we know nothing about one number, and the other one is 3 times the first one. So these are our two numbers. Okay, now we're told the sum of their reciprocals. So the reciprocal of x is 1 over x, and the reciprocal of this guy is 1 over 3x, and we're going to add those together. So I have 1 over x plus 1 over 3x equals 8/3. Well, now this looks just like a problem that we would have had in the last section. We need to create a common denominator. So I'm going to multiply this guy by 3. This already has a 3x. This guy by x. So now my equivalent fractions are 3 over 3x plus 1 over 3x equals 8x over 3x. I can then move this guy to the other side and write everything as one fraction, essentially. So I have 3 plus 1 minus 8x over 3x, and that's all equal to 0. Now I can multiply. Well, let's combine like terms first. So I have 4 minus 8x over 3x equals 0. Multiply by the denominator. So this cancels this, and 3x times 0 is still 0. So I have 4 minus 8x equals 0. Bring the 4 over. Well, let's bring the 8x over since it's negative. So 4 equals 8x. Don't say x is 2 either. Divide by 8, divide by 8, x equals 1/2. So remember that originally our two numbers were x and 3x. So x is 1/2, and then 3x is going to be 3 times that. So, and these would be the two values that you would put into varsity as your answers. Okay? Let's see. I had another one similar. I don't think we need two exactly the same type of things here. So let's see. All right, so example 2. The sum of the reciprocals of two consecutive integers is 19/90ths. Find the numbers. Okay, well, here's a couple things you need to know. Integers are whole numbers. They can be positive, negative, zeros, and integer, but they're whole numbers. They are not fractions, okay? And if you have consecutive numbers, that's like 2 and 3 are consecutive, 11 and 12 are consecutive. So when you see that, you're going to have one number is going to be x, and the next number after that, you add 1 to it, right? 2, 3, 4, 5, 6. Each of these are groups of consecutive numbers. You add 1 to get to the next one. So x and x plus 1 are consecutive. All right, now that goes over there. Now we need the reciprocals of those consecutive integers. So the reciprocal of this guy is going to be 1 over x. The reciprocal of this guy is going to be 1 over x plus 1. And the sum of them is 19/90ths. Remember that the word is means equals. Okay, find the numbers. So we've got a little bit of some math to do here. And we need to find a common denominator first. And that common denominator is going to have all three of these pieces, right? So we'll work from left to right. The x is already in the first equation, but the second one needs to be multiplied by an x, top and bottom. So does the 19. Okay. Then the next one is an x plus 1, which you already see in the middle, but this top one's going to need an x plus 1. And this guy over here is going to need an x plus 1. All right. And then we have on the far right, we have a 90 in our denominator, which is already on the right-hand one, but we're going to need that on the left. And we're going to need that in the middle. All right. So that gives me 90x plus 90 plus 90x from this term. And this is all over 90x times x plus 1. And this is equal to 19x squared plus 19x. And this is over 90x times x plus 1. All right, well, we know that we can multiply this entire thing by 90x times x plus 1 and get rid of the multiplier and the denominators, right? So that now leaves us, let's combine some like terms. We have 180x plus 90 equals 19x squared plus 19x. And you know that we want to make sure our x squared term is positive. So I'm going to bring these guys over here with subtraction. So we're going to subtract off 180x and subtract off a 90. And that's going to leave us 19x squared minus a 161x minus 90. I have a plus 90 on my paper. That's weird. That's definitely a minus 90. Okay, equals 0. And then you have a quadratic. So now you have to make some decisions. How do you, as the student, prefer to solve a quadratic? You have 3 ways. Do you remember all of them? You can either factor, my go-to personally. You can use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Or you can complete the square. Something I would never do on this particular problem, because remember, when you complete the square, your a has to equal 1, and if it doesn't, you have to divide, which means you're dividing all 3 of these terms by 19, and that's just gross. So quadratic formula or factor. All right, so here's the deal for this. If we factor this guy, we have 19 times 90, which is 1710. And a negative 161 in the bottom, which means we're going to subtract these values. And so a negative 171 and 10 actually works. I'll use blue. Negative 171 and 10. And then we have to divide by 19 and divide by 19. And would you believe 19 goes evenly into 171? And this is negative 9 over 1. So we're going to use that, and we're going to use this to factor into x minus 9 and 19x plus 10 equals 0. And then we're going to set each factor equal to 0 and solve. So those are our two factors of our two values of x. However, remember at the beginning, we were told that an integer, which means a whole number, which is clearly only this and not this, is going to answer this question. And so we had two consecutive integers. They were x and x plus 1. So if x equals 9, then x plus 1 equals 10. And these are our two integers that we are going to answer that question with. All right. There are a few others in varsity that I did not model, but I think that you now have the ability to go and solve those without me modeling them first. So let's see how smart you are. I have faith in you. All right, giddy up. Toodaloo.